The height we can get using Pythagorean's theorem. That's what I do here. Now, it's not hard to do. It turns out to be the square root of 3. So this is, I think, what they call a 30, 60, 90 triangle. In fact, okay, you can actually now get sine. Once we know what h is, which we do, we can easily get sine, cosine, and tangent of 60 degrees and of 30 degrees. I mean, it's just unfolding definitions. It might be a little weird because for 30 degrees, that's up here. But remember, when we had opposite side, OPP, that was the side opposite the angle. So when you're dealing with 30 degrees, OPP becomes this side. That's the opposite side. And the adjacent side becomes this. You know, it's just unfolding definitions or unpacking if you want. You can think of it that way. That's all it is. So sine of 60 degrees is opposite over hypotenuse. That's down here. So 60 degrees is pi over 3 radians. 30 degrees, the opposite now is 1, and the adjacent is radical 3. So sine of 30 degrees is opposite 1 over hypotenuse 2. For cosine of 60 is adjacent over hypotenuse 1 over 2. Cosine of 30 degrees, right? This is 30. That's going to be the adjacent side over the hypotenuse. Here. Hypotenuse is always the side opposite the 90-degree angle. That doesn't change. And then you have tangent and so on. Okay. All right, that was fun. I think, oh yeah, the other trig functions I have here as well. So I guess for these, you could use the formal definition, but you could also use sine, cosine, and tangent. So you could do that. So I thought it would be nice to go through these kinds of proofs, but now I want to do another example. Okay, and again, what's nice is since we have calculators, we don't have to remember what sine of 30 degrees is, what's cosine of 45 degrees, that kind of. We don't have to. Those are programmed into our calculators. Here, in this example, here I'm telling you, so here basically I'm giving you a right triangle, where by assumption, this is 37 degrees. The right triangle, this is that right angle. This is 40 of side length. What we're going to do is figure out what A and C are using trigonometry. This actually shows us why trig is so useful. If you know one side and you know the angles, you could figure out the other side lengths easily. Let me just say this, that when we get to 2, without finding A, without using A, excuse me, find C, there you can't use A. So if you know what A is, but you want to get C, we're going to do that without Pythagorean's theorem. I mean, theoretically, you could use Pythagorean's theorem, but this is trig, so let's just use trig for now. So let's find A. Well, the tricky part is, how do we, in finding A, or C, I guess, when we find A, what trig function do we use? Well, we have the adjacent side, don't we? That's 40. Remember, this is relative to this angle. 40 is the adjacent side, the side adjacent to the angle. A is the opposite. So we have opposite. We're dealing with opposite and adjacent. Opposite and adjacent. What trig function comes into play? Tangent. Tangent of 37 degrees. Tangent of 37 degrees is opposite over adjacent. So this equation. Now, how do we get A? Well, now it's just basically algebra. Just, get A all alone. We multiply both sides by 40. For the tangent part, here you're going to have to use a calculator make sure your calculator is in degree mode. You know, if it's in radian mode and you type in tangent of 37, it's going to think you want tangent of 37 radians. But we want degrees. I mean, this is what you get when you use the calculator. And so A then turns out to be this. So you just multiply. I rounded it to 4 decimal places, so I'll tell you how many decimal places to round to. I will do that. Now that's A. Okay, now without using A, we're going to find C. Okay, well, without using A, so we can't use Pythagorean's theorem, right? But what can we do to get C? Well, here's our angle. 40 is still the adjacent side. C is the hypotenuse. So adjacent, hypotenuse. Adjacent, hypotenuse. What trig function do we use? Cosine. Cosine of 37 degrees is adjacent divided by hypotenuse. What I have here. So what do? We want C. So just like what we saw earlier, essentially we're going to cross multiply and get C times cosine of 37 degrees is 40. Then dividing, you get this. But you can see that essentially C and cosine of 37 degrees is switching positions essentially. You know, it's just basic algebra. And as before, we want to know what cosine of 37 degrees is. Well, again, that's in our calculator. So I would check right now if you put in 37 degrees, cosine of it, you get this. Make sure you know how to put it in degree and radian mode. You know, the iPhone calculator, you can do that. I'm sure the Android, I'm sure that comes with a calculator you can do that with. Anyway, you get C is this, which turns out to be this. I mean, if you try Pythagorean's theorem, your answer might be slightly different. That's kind of expected because A, we approximated since we rounded. So since we rounded to so many decimal places, you know, that's why our answer is going to be kind of different. Oh boy, I'm out of space. All right.